In this video, I want to talk about slope, which really talks about how steep a line is and also which direction it falls. So your slope here gives the steepness and direction of the line. So let's look at some examples, and I want to really just show you what slope is, and then I'll show you how to find it. So there's really four things that can happen. So the first is that you have a graph that is increasing. Now, we always read graphs from left to right. So you have a graph that is increasing, right? So when you have a graph that is increasing, we're going to find that the slope is positive. And actually, the variable that we use for slope is m. So we could write m is greater than 0. And again, I'll show you how to find the slope in a little bit. I just want to talk about what it represents. So it represents the steepness and the direction of the line, meaning, is it going up? Is it going down? How is it falling? So if you have a positive slope, you have some sort of increasing line. If your slope ends up being negative, you have a decreasing line. So it goes down from left to right. So we're going to see here that our slope is negative. So your m value is less than 0. Now, it can also happen that your line is horizontal. Right? We've seen examples like that, right? That's when you have that y equals some sort of number here. So when that happens, actually, your slope is exactly 0, which makes sense, right? If your slope is positive and your graph is going up, and your slope is negative and your graph is going down, well, what's in between up and down is perfectly flat. And what's in between positive and negatives, well, it's 0. So a 0 slope means it's perfectly flat. And then the last example, I'm going to just kind of put it down here, I'm running out of room, is a vertical line. This is when x is equal to some number. And your slope is actually undefined. Okay. And I'll tell you a little bit why it's undefined. So, and we'll see some more examples later, but if you think about it this way, is this line increasing? Is it decreasing? We could disagree, right? I could say it's going up, you could say it's going down. So we can't really tell what direction it's going. It's almost like an infinity idea, right? It's like perfectly going straight up and down forever. So we say something like this is undefined. The slope is undefined, okay? If you have a vertical line. So this is the direction part of it, right? So the sign of the slope, positive, negative, or 0, undefined, also tells you the direction of the line. Is it going up? Is it going down? Is it flat? Or is it a vertical line? Now, the second thing that you're going to notice here with slope is that the larger the absolute value of slope, the steeper the line. So, for example, okay, so let's say, and again, this is not drawn perfectly, but this could be something with a slope of 1, and something like this maybe is a slope of 3. Okay. Now, the absolute value of 3 is bigger than the absolute value of 1, right? Because the absolute value of 3 is 3, and the absolute value of 1 is 1. So the larger the absolute value, the more straight up and down the line goes. And that's also true with negatives. So, this could be a slope of -1, and then maybe this is a slope of -3. So what happens is the absolute value of -3 is greater than the absolute value of -1, right? Because 3 is greater than 1. So the larger the absolute value, the steeper that line becomes. So your slope represents the direction, but also the steepness. So that larger value here, or a larger, in this case, I guess, more negative value, creates a much steeper, more vertical line. So as the slope gets closer to 0, the line gets flatter, right? So it gets less vertical, more horizontal. All right, so that's just a little bit of background about what slope is. So now how do you find slope? And there's actually quite a few different ways to find slope. So I'm not going to go through every single thing about slope in this example. This is meant to just be an introduction class to this topic, but I do want to talk about the most important parts. So first of all, again, at slope, we use M for slope. So M slope is really related to the vertical change in the graph compared to the horizontal change in a graph. It's actually a ratio. So a slope is really the ratio of what's happening up and down versus what's happening left to right. So you can think of this also as your change in y values over your change in x's. So again, slope is really a kind of ratio, which we learn lots about. Now, the symbol for change in math is it's technically a Greek letter D called delta, but everybody thinks of it as a triangle. So if you see a little triangle, it's actually a delta. That means change. So sometimes you'll see the notation like this, change in y over change in x. And there's also a specific formula that we use a lot when you have actual points. And I'm going to start with this here. So what you do is you subtract your y values over the subtraction of your x values. So let's do an example. So I want to find the slope of the line between the 2 points, 1, 2, and -2, -5, and I also want to graph the line. So let's find the slope first. So I'm going to use this formula here. This is a very common formula that we use. And I'm going to show you what it means. Okay. So in my 2 points, everything is always x, y, right? But because I have 2 points here, we're going to call one point 0.1 and call one point 0.2. And it doesn't matter which one you pick. Doesn't matter, you get the same answer. So what we do is we use these little subscripts to let everybody know that, hey, this is going to be 0.1, x1, y1. This is going to be 0.2, x2, y2. And then what I'm going to do is I'm going to substitute my values into the formula. So here, my y2 value is -5, and my y1 value is 2. And be careful, there is a subtraction sign in between. And I do the same thing for the x's. My x2 value is -2. My x1 value is 1, and be careful, there's always a subtraction sign in between. So what you're doing here is you're subtracting the y's and you're subtracting the x's. And for slope, we always look at the vertical change over the horizontal. If you mix up the order and you put the x's on top, it's going to be wrong. So it's always the vertical to the horizontal ratio. And now you're going to simplify. So you can always do your keep change here for subtraction. I have -7 over -3. So my two negatives cancel here, and I have 7/3. Now you do simplify your fraction, but we typically don't write it as a mixed number. We typically like to leave it in the ratio format. So I'm going to leave it like this. And I'm also going to graph this just so you can see what it looks like. All right, so there's 1, 2. So here's my first point, 1, 2. And then let's see, we got to go up to -2. and then 1, 2, 3, 4, 5. So I'm looking at this point right here. So notice that I'm graphing my original point so you can see what it looks like. So there's my graph. This time I didn't have to find the points on my own. They gave me the points, which is kind of nice, saves me some work. And notice here that I have a positive slope. And my line is increasing. So you can see that it is going up. It is an increasing line with a positive slope. Now, the other cool thing is that you can actually see the slope on the graph. So see I have my little 2 points here. I'm just going to draw a little triangle between them, just lightly, just to help me visualize. And I'm going to count the lengths of my 2 sides. So here, if I start here, I have 1, 2, 3. So I'm counting the tick marks. I see a length of 3. And if I count from this way, I see 1, 2, 3, 4, 5, 6, 7. I have a length of 7. So my change in y's over my change in x is 7, right? Because that's my vertical direction. That's the y direction. And then the x direction is this way, 3. So see how it matches? So you can visually see that slope on the graph, not just from the formula, but you can physically see the counting. So there is your slope. So we can find it using a formula, but we can also see it between points on a graph. And the nice thing with slope is it doesn't matter which 2 points you have, you're always going to be able to find the slope. So slope is consistent on a line between any points. So if I gave you like 10 points to choose from, it doesn't matter which 2 you choose, you're gonna get the same answer for slope. All right, let's do it again. Oh, sorry, find the slope between the 2 points. And graph the line. Okay, so here are my 2 points this time. I'm going to use the points 0, -5, and 1, -10. So I'm going to start with the slope first. So here's that slope formula that we always use when you have 2 points. So I'm going to label everything. So it's always x, y, x, y. And then you just pick one to be 0.1 and one to be 0.2. It doesn't matter which one. But you just want to be consistent. So here, when you use that y2 or x2, you always are starting with the same point, right? So here my y2 value is -10, minus sign in the middle. My y1 value is -5. My x2 value, so notice I'm going back and starting with the same point I did as I did up top. It's 1, minus, and then 0. Watch out for those minus and negative signs. That's the biggest thing that kind of trips students up, or they change up their order. They don't put things in the right order. So just be really careful here. So -10 plus 5 is going to be -5, and 1 minus 0 is 1. So I have a slope of -5. All right, so I'm gonna have to make this longer. Sorry, guys. Let's see. I have 1, 2, 3, 4, 5, 6, 7. So there's 1. 1, 2, -1. All right, 1, 2, 3, 4. Okay, here's -5. Let's see, 6, 7, 8, 9, 10. I gotta make it a lot long. -6, 7, 8, 9, 10. All right. So let's graph our points here. So I have 0, -5, which is right here. And then I have 1, -10, which is right here. And I'm going to do my best to try to line up these points here. They're a little hard to get here. This does not seem right. I think my scaling is up. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 1 and that's 0. All right. Well, I'm gonna go for it. My scaling looks a little bit off here, but I'm just gonna connect these together. All right. So I apologize. This one's a little bit messy, but you can get the idea. All right. So what I want you to notice here is that I have a negative slope and a decreasing line, right? So we see that same pattern. And if I want to look at the actual change between those 2 points, right? So I can just draw a triangle. It doesn't matter how I draw my triangle. Just kind of look here. So this way, I see a change of 1. In this way, I see a change of 1, 2, 3, 4, 5. If I look at my change in y over my change in x, I see that 5 over 1 change. Now here, the overall graph is going down. So it is going to be a negative 5 change, right? Because I'm going in the downward direction, whereas in the last time I was going in the upward direction. But I can see that it matches that slope. So I can see the slope visually on my graph, which I think is pretty cool, honestly. Now, this also still works for vertical and horizontal lines. So notice, for instance, let's say I have a vertical line. Let's say I'm looking at x equals 4. So I know my graph is going to look like this, right? So what happens here, if I have a vertical line, let's say I pick out 2 points in the graph. So I'm going to use the point 4, 0. Let's see, 1, 2, 3. I'm going to use the point 4, 3. I'm going to find the slope here just to kind of show you what happens. So I'm going to subtract my y values first. So this is going to be x, y, x, y. I'll make this 0.1 and 0.2. So I'm going to have 3 minus 0 on the top, and then 4 minus 4 on the bottom. I end up with 0 over 3. And remember that division by 3 is undefined. So this also works. I know we already said that vertical lines have undefined slope, but this is another reason why they're undefined. When we try to use 2 points, we get that division by 0. So you're going to see that in your examples. And if you have something like, let's do y equals 3. So here would be my horizontal example. And again, maybe I just use 2 points. So I'm going to use the point 0, 3, and I'm going to use the point 2, 3. This can be my first point, and this can be my second point. So my y values would be 3 minus 3. My x values would be 2 minus 0, and I have 0 over 2, which is just 0. So in the beginning of this video, let's see if I can find my notes here. I showed you guys what to expect for slope, that horizontal lines give 0 slope and vertical lines give undefined slope. And those 2 ideas also check out with our formulas. So you want to remember in mathematics that we should never be contradicting ourselves. We should always be building on ourselves. So those ideas of 0 undefined are still consistent whether you're just looking at the picture, right? Because we can see like something is flat and it makes sense that the slope is 0, right? But it also works out with the formula. So we see that again. So this formula here, this y2 minus y1 over x2 minus x1, is a really, really, really common formula that we often use. Now there's lots of ways to find slope, but there's another way to find slope too that we often see. And that's with an equation. Can find so the equation looks like this. So this is called slope intercept form. And your equation looks like this. And what I want you to notice is that it is solved for y. So when your equation is solved for y, because they don't always have to be, we have seen some examples in other videos where they are solved for y and where they're not, and I kind of just didn't really stress the difference between them. So let me see if I can just really quick show you guys. All right, so this is a few videos ago, but you can see here's an example where we started with graphing, and you can see that this example is not solved for y, right? Y is not by itself. But I did another example after that where y was by itself. So your equations don't have to be written in this form, but when they are, it tends to be really helpful because what happens is the number next to the x is your slope. So this is your slope. And the other cool thing is that 0b, whatever that b is actually your y-intercept. So when your equation is written in this particular form, you actually get a ton of information right away from it. So for example, y equals 2x plus 3. Now, you have to be solved for y or this does not work. So don't try this if you're not solved for y. But you can see right here, the number with the x is your slope. So our slope is 2. And then the other cool thing, I know we're doing slope right now, but this 3, so your b value is 3 here. That means your y-intercept is 0, 3. So again, this is always 0. So I actually get a lot of cool information right away from my examples. Let's do another one. Y equals negative x plus 4. Okay. Now, there is no number there, but there is a 1. So your slope is negative 1. Your b is 4. So your y-intercept is 0, 4. So again, I get a lot of information without having to use a ton of difficult formulas. Let me do just a couple more examples of this that are a little bit more challenging. So let's say I had something like y equals 5 plus 6x. Now it's solved for y, right? But notice how it's kind of written backwards. So let's try to straighten this out here. Okay. So your slope is with the x. So even though this one's written backwards, I can still find my slope. My slope is here, and then this is my b. So my y-intercept is 0, 5. Let's say I have y equals 2x. Well, my slope is with the x, and if I have no b, then the b is 0, right? Because it's missing. So your intercept here is just 0, 0. Similarly, if I have something like y is equal to negative 5, okay? So notice that there is no x. So if there's no x, your m is 0. Okay, this happens to be a horizontal line. And then this is your b. So your y-intercept is 0, negative 5. Now, if you're not in the right form, so maybe I have a problem and it's 2x plus 3y equals 6, and you want to use this. Well, what you can do is you can always solve for y to find the slope. Okay, so my question here is going to be to find the slope. So I want to solve for y, I want y by itself. So to do this, the first thing I'm going to do is I'm going to bring the x to the other side. So I'm going to subtract 2x from both sides. But it's a little bit tricky because 6 and 2x are not like terms. So what we do is we just write it next to each other. And then I'm going to go ahead and divide everything by 3. So I have negative 2/3 x. Now 6 divided by 3 is 2. So I can get it in the other form, but it may take me a little bit of work. So typically what you have to do here is move the x part to other side and then divide by number with the y. Now, there could be some discrepancy there if you don't always have a number with the y or something like that. But in general, we're just using our solving techniques here. So we're going to add or subtract first, move that other piece to the other side, kind of like pretending it was a regular number. And then we're going to divide by whatever's with the y. So let's do another one. Let's say I have x plus 6y equals 2. Okay. So I'm going to move that x to the other side first. If it's positive, it becomes negative. This was negative, I'd use positive. And again, I just like to write them right next to each other like that. I like to put the x first. That's more comfortable. And then we're going to divide everything by 6. Now, there is a number here. It is 1. So I am going to actually put that in so I can see my slope a little easier. And then for 2 over 6, I can divide those both by 2 and get 1/3. So here is my m. Here is my b. So my y-intercept is 0, 1/3. And there's lots of different style problems that we could do here. I'll just do one more. So maybe I have negative 4x plus y equals 0. So I can still start by bringing that 4x over. So this time, because it's negative, I'm going to add it to both sides. And I actually don't even really need the 0 there, so I can just kind of get rid of that 0. And here's one where I don't have to divide by anything, right? So the y is already by itself. So here is my m. And if there's nothing there, my b is 0. So my y-intercept is 0, 0. Okay, so we just have this sort of 2 basic steps that we can do here, but we may not always have to do it. So maybe I have something like this. 3y equals 6x plus 9. And you're saying, well, it's almost there, right? The x is already over, but the y still has a 3. So here I may only have to do one step instead of both steps to move everything around. So just another way that we find slope. And again, slope is as a very, very common application. We do use it a lot. So what I did in this video today, we're not doing every little detail with slope. There's a lot that we can do. And you'll do that in your next class, is my guess, depending on what you take next. But today what I want to talk about is just the 2 kind of main calculations that we do with slope, or how to find it. So the first one that we saw was that formula here that we use when we have 2 points. So that's what you're going to use when you have 2 points. Very easy, in the sense that it's the same formula. Anytime you have 2 points, you just go ahead and plug them in, and you can get your slope. If you have an equation, then what we do is a little bit different, right? If we have an equation, then instead of using 2 points, we want to get it into this y equals form. And that is the fastest way for us to find the slope. So for us, there's 2 main ways that we can find slope. We can use that first formula if we have 2 points, like if I have a graph or something like that, it's pretty easy. I can pick my points right out of the graph. Or if I have an equation, then I can go ahead and make sure y is by itself and find the slope that way.